All right, friends, today for classwork, you're going to be looking at Lesson 17, Two Related Quantities, Part 2, practice problems. And so you can see that these problems kind of look like what we did yesterday for notes, so having your notes out might be useful. So it says a car is traveling down a road at a constant speed of 50 miles per hour. So that means that for time, 1 hour, they're going 50 miles, right? So what is the relationship between 1 and 50? You're going to fill out this table using that relationship. So when time is 2, what's the distance in miles? Here, when they give you this variable, it's asking yourself, what are you doing to this side? So like, what's gonna find your answer over here? So like, I know to find my answer, I'm gonna have to multiply by 50, right? So this one's right here is asking you to do the same. So what is 50 times t? That's what you need to be asking yourself. When you get to this one right here, it's kind of like working backwards. So if you're multiplying by 50 to get your answer here, then you should be technically dividing by 50 to get your answer here. So this would be, this divided by 50. So how do you represent that? And then the second, so that's completing the table. So that's what you do for part A. For part B, it says write an equation that represents the distance traveled by the car, d, for the amount of time, t, right? So we know, right? So this is like taking our constant. We know that in 1 hour, right, the car can travel 50 miles. So if I'm going to write a distance equation, d equals, right? D equals what is my constant and what am I multiplying that constant by? That's going to help you write your equation, right? So like, what do I know? How many miles can they travel in 1 hour? And then what's the variable for the other quantity? In your equation, which is the dependent variable and which is the independent variable? When looking at your equation, which one depends on the other? That's going to help you establish your dependent variable from your independent variable. So you have to look at your equation and say, okay, I have to know this in order to calculate this. What do you have to know in order to solve for your equation? So that's going to be part 1. In part 2, you're going to get a graph, and it says the graph represents the amount of time and hours it takes a ship to travel various distances in miles. And so you can see that they've graphed these points for you down here on the x-axis. This is, this is x, and this is y. Right? You can look at where these points line up. So it says write the coordinates of one point on the graph. What does the point represent? Well, you could pick any point on the graph, but what I'm going to do is ask you to look at this point. So this represents distance, so that's 25, right? And this represents how many hours that is. So notice that this is blank, so you have to figure out what this is. So I know that this is 25, and we have to figure out how many hours that is. And so we have to ask ourselves, so if we write the coordinates, right, x comes before y in the alphabet, right? So the same thing needs to apply here. So I know that this is 25. What is this, right? So, and then what does the point represent? So this represents 25 miles in how many hours, right? So that's what you're going to be looking at when you do that problem. On the back, you're still looking at that graph. So what is the speed of ships in miles per hour? So this question is asking you, how fast is the ship going in 1 hour? So that's why I asked you to remember to look at that first point, because that point tells us our unit rate. It also tells us, how fast it's going in 1 hour, so that we can calculate anything after that using an equation. This says write an equation that relates the time it takes to travel a given distance. So for this one, I could say d equals, right, how many, or my constant is 25, and then I need to write something next to that. So you have to figure out what needs to happen there, right, because 25 is going to be my constant. That's how many miles it can travel in 1 hour, so how many miles can it travel in 2, etc. What you put there. In question 3, this is reminding us to go back and kind of look at things to help us, for the future. It's asking you to figure out what x equals in each equation. So this one right here saying 2 to what power gives you 8. So looking at this list down here, you're going to establish 2 to what power gives you 8. So you pick from this list, and then you prove it, right, by writing it out next to it. Again, this is 2 to what power gives you 2. Some number to some power gives you 100. Some number to some power gives you 1 over 100, or 100th. Some number to the first power gives you 7. This one right here, this is using a rule, right? We learned the rule, so this and this should be added together to give you this, right? So that's the rule. And then here, this top one minus this one should give you this. So you should be able to apply those concepts here. And then this one is my favorite question of all, because you have to understand how to find expressions that are equivalent to this, or things that are going to equal this. Now, for the purposes of doing this, right, there's going to be a couple things that you need to establish. One, all these are x's, right? So that means that I can combine them because they are like terms. So I can also write this as that's 35x minus 15x, and then I can subtract that. So that's the same thing as 20x. So when you actually look through these equations, right, you need to use the distributive property, right? And distribute means that you're going to multiply this number on the outside by each of these. And if it matches this equation or this, then it's technically equivalent. And that's seen if you understand that. And then on this last part, right, it says relating to what we did in class during a walkathon, notice time and hours and distance in miles are related by the equation 1/3 d equals t. A graph of the equation includes the point 12,4. Identify the independent variable, right? So independent means that it does not rely on the other. So in this equation, d can be changed, right? So when they gave us 1/3 d equals t, the thing that's going to change is the distance, and that's going to tell us the time. So therefore, we can say that d is what variable? What does the point 12,4 represent in this situation? Well, if this is, 12,4, if we're looking at it like that, this is that, this means that Noah can travel a certain distance in a certain amount of time, right? So this is going to refer to distance, and this is going to refer to time. And then this one is asking us to plug this number into the equation they gave us. So 1/3 times 7.5. Now when you get this sort of problem, remember that you need to write this as an improper fraction to actually solve the problem. So you remember, to make an improper fraction, you're going to need to do 2 times 7 plus 1, and that's going to give you 15 halves. Okay, so that should be everything you need to be successful today.